Fluorescence can be an effective way to make invisible stains visible, and in this video I'll explain how we use this technique to solve a complex inspection task for a company in the medical industry. The goal for this pharmaceutical company was to find a better and more efficient way to detect residue from medicine from the production line. The problem is that when the residue dries up, it becomes transparent and impossible to see with the human eye. The previous solution was to shine a flashlight at different angles because since the surface of the residue is smoother than the background, at the right angle you can see a difference in the direct reflection of the light, which then makes it possible to see the residue. However, this is a difficult and tedious manual process. To automate the inspection, we have studied the stains to find out how much light it absorbs at different wavelengths and found that we can use fluorescence to highlight them. It works like this. When we shine ultraviolet light on the stains, the light pushes the electrons in the atoms, and when they bounce back into place, so to speak, they release energy by emitting light with higher wavelength than what we used. It becomes visible in the visual spectrum and it shines in all directions. The fact that it shines back in all directions is a great advantage for both inspection because it then becomes visible from all angles, meaning we are no longer forced to find a precise angle to see the stains. And this increases the accuracy of the inspection significantly. This type of inspection works best with low wavelength UV light. We have tested with both 400 and 365 nanometers, and the low wavelength yields the best results because it holds more energy and therefore creates a more distinct fluorescent effect. The technique has some limitations as it requires a certain amount of substance to create the fluorescent effect. If the stains of films are less than 10 micrometers thick, it becomes difficult to see with the human eye. However, from the right angle, even the very thin films will still be visible. When working with fluorescence, it's important to make sure you block the visible light that is also emitted from the UV light source. If the visible light mixes with the ultraviolet light on the surface, you get a poor contrast, so we solve this by applying a filter that blocks the visible light. This allows us to make the invisible visible, so in this case we can ensure that spilled medicine residues can be effectively removed from the production line.